Dear students, in this video we are going to see Coulomb's inverse square law. This is the topic we are going to discuss in electrostatics, which is in class 12. First of all, we should know what Coulomb's inverse square law says about. Coulomb's inverse square law says about the force between 2 point charges. See here, there are 2 point charges Q1 and Q2. They are placed at a distance r, that is the distance of separation between the two charges is r. They are placed in free space. This epsilon naught represents permittivity of free space. According to Coulomb's inverse square law, the force between these two charges is directly proportional to product of the magnitude of these two charges, that is the product of Q1 and Q2, and the force between them is inversely proportional to square of the distance between them, which means, see, when the product of these two charges increases, the force also increases. When the distance between the charges increases, the force between them decreases. But see the relation, if the distance between the charges is doubled, then the force decreases 4 times, because if you put instead of r, if you put 2r instead of r, 2r whole square, you will get 4r square, which means when the distance increases 2 times, the force decreases 4 times, that is 2 square. If the distance increases 4 times, then the force decreases 16 times, that is 4 square 16. This is the meaning of this law. See here, let us remove the proportionality symbol and put a constant. Here constant is this 1 by 4 pi epsilon naught. So we can write F naught is equal to, this naught represents the charges are kept in free space. So F naught represents the force between the 2 point charges in free space. So F naught is equal to 1 by 4 pi epsilon naught into Q1 into Q2 by r square. Just we have put a constant in this equation. So the proportionality symbol changes into equal. Here the epsilon naught is called as permittivity of free space. The permittivity of free space, the value of permittivity of free space, epsilon naught is 8.854 into 10 power minus 12 Coulomb square per Newton per meter square. And if you put this value, that is instead of epsilon naught here 8.854 into 10 power minus 12 and pi value 3.14, you will get the value of 1 by 4 pi epsilon naught is 9 into 10 power 9 Newton meter square per Coulomb square. See here in this 1 by 4 pi epsilon naught, only the epsilon naught has unit, 1 by 4 pi doesn't have unit. So the epsilon naught, see here the epsilon naught is in denominator. What is the unit of epsilon naught here? Coulomb squared per Newton per meter squared. So 1 by 4 pi epsilon naught means here the unit of 1 by 4 pi epsilon naught will be the reciprocal of this unit, Coulomb square per Newton per meter squared. If you take the reciprocal, you will get Newton meter squared per Coulomb square. So the unit of 1 by 4 pi epsilon naught is Newton meter square per Coulomb square. So remember this unit. And now see the two charges, the same two charges are placed in a medium, some medium, maybe water or some other medium, oil or some other gas, whose permittivity is epsilon. Epsilon is the permittivity of the medium. So here the same two charges are placed in medium with the same separation r. Now the force between them is called Fm. Fm means M stands for medium. So Fm represents force in medium. So force in medium, see, compare these two equations. Here these two equations are similar except this epsilon naught and epsilon. Here we have put epsilon naught, here we have put epsilon, because here the charges are placed in a vacuum or free space, here the charges are placed in a medium. So this is the only difference. So this is the difference. Epsilon represents permittivity of medium. Now just divide 1 by 2. Divide 1 by 2. That is equation number 1 is divided by 2. See the left hand side F4 in equation number 2 Fm. So F4 by Fm is equal to what we get here. See everything, that is Q1 Q2 by Q1 Q2 get cancelled. 1 by 4 pi 1 by 4 pi get cancelled. If you divide, then r squared get cancelled. So only we will have 1 by epsilon naught and 1 by epsilon. So if you divide 1 by 2, you will get 1 by epsilon into epsilon by 1. Okay. See this f naught by fm is equal to epsilon by epsilon naught. This ratio is called as epsilon r. That is the ratio of f4 to fm, and the ratio of epsilon to epsilon naught is called as epsilon r. This is called relative permittivity of the medium. Relative permittivity of this medium. Okay. So relative permittivity is the ratio of permittivity of the medium to the permittivity of free space. Or we can define the relative permittivity as the force between two charges in vacuum to the force between the same two charges with the same separation in medium. Okay. Then the relative permittivity is the ratio of two similar quantities. Permittivity, force. So it doesn't have any unit. It is a number, mere number. So here, see f naught by fm and epsilon by epsilon is equal to epsilon r. This is called relative permittivity. It has no unit. And see the value of epsilon r. Epsilon r is equal to 1 for air medium. If it is air, then epsilon r equal to 1, because what is this? Epsilon is the permittivity of medium, epsilon r is permittivity of free space. If you compare the permittivity of air to the permittivity of free space, then there will be no difference. Both are equal. Permittivity of air and permittivity of free space, both are equal. So you will get the epsilon r value is 1 for air medium, and for all other medium epsilon r is greater than 1. So from this, see f4 by fm equal to epsilon r. So if you bring this fm here, we will get f4 equal to epsilon r into fm, which means, see what we said just now, epsilon r is greater than 1. If you put minimum 2, greater than 2 means minimum 2. If you put 2, then this f4 will be 2 times of fm, which means if fm is 5 Newton, for example, I say, then f4 will be 2 into 5 Newton. It will be 10 Newton. Okay, it will be 10 Newton. So f4 is 10 Newton, fm is 5 Newton. So always f4 is greater than fm. That is very important point. f4 is always greater than fm. That is, force between two charges in vacuum or free space is always greater than the same two charges, force between the same two charges with the same separation in medium. Okay, this is very important conclusion. Next, let us see the vector form of Coulomb's law. Here, see the same two charges Q1 and Q2 are separated by a distance r. Here, this r12 cap is a unit vector which points the direction in this direction. This is a direction. r12 cap is the unit vector whose magnitude is 1. Its value is 1, but its direction is from Q1 to Q2. That is this direction, towards right, this direction, from the charge Q1 to Q2. This is a direction. See the force experienced by this Q2 due to this Q1. See, both are like charges, positive charges. So we know that the like charges repel each other. So Q1 will push Q2 in this direction. So this the force experienced by this Q2 by Q1 is written as F21 vector. See, 2 is written first, which represents the force is acting this 2. The 2 comes first. This represents force is acting on this charge. Okay, due to what? The Q1. So we should write in this way, F21 vector. So F21 vector represents what? The force acting on 2 due to first charge. Similarly, F12 vector represents what? the force acting on Q1 due to Q2. That is, the Q2 pushes the Q1 in this direction. So now let us write the vector form F12 vector. Sorry, F12 vector. F12 vector means, see, there is a mistake here. I have corrected. This is F21 vector. This vector is equal to, see, 1 by 4 by epsilon naught Q1 into Q2 by R squared. See the unit vector R12 cap. Because this F21 vector, see the direction of F21 vector. This is the direction of F21 vector. So which is along the direction of R12 cap. What is the direction of R12 cap? This is the direction. So these two directions are same. So the direction of F21 vector is along the direction of R12 cap. Okay. Then see the F12 vector. F12 vector means force acting on the Q1. So F12 vector equal to the same. Both the forces are F21 and F12 are equal in magnitude, which means they have same value but they are different in direction. So F12 also the magnitude 1 by 4 by epsilon naught Q1 into Q2 by R squared only. But see the direction. This F12 vector is acting in this direction. So which is opposite to R12 cap. R12 cap is along this direction towards right, but F12 vector is towards left. So the F12 vector is opposite to R12 cap. That's why we have put negative sign here, R12 cap, minus R12 cap. All other things are same. So we can take this minus sign to the front side. Here, rest of the things are same. So we can write like this: F12 vector equal to minus of 1 by 4 by epsilon naught Q1 into Q2 by R squared into R12 cap. See, this is nothing but what we have seen. This is what we have got. This is equal to F21 vector. So here we can write F12 vector is equal to minus F21 vector, which is equal to F21 vector. So F12 vector equal to minus of F21 vector, which means the two forces, that is force between the two charges, force experienced by each charge is equal but opposite. They are equal in magnitude, but they are opposite in directions. So the Coulomb's inverse square law obeys Newton's third law. Okay, this is the conclusion we arrived. One more conclusion we have arrived. Now let us solve a question. See, this is a just a NEET question. Already it has been asked in a NEET exam. A little bit complex question. Already I have told we will solve, we will practice difficult questions, because if you solve and practice some difficult questions, automatically you will be able to solve easy questions. So here first let us solve this question. See the question: two identical tennis balls, each having mass m and charge q, are suspended from a fixed point by threads of length L. What is the equilibrium separation when each thread makes a small angle theta with the vertical? This is the question. So first let us understand the question. What is given? Two identical tennis balls are suspended from a fixed point by thread of length L. These are threads of length L. These are tennis balls. What is the equilibrium separation when each thread makes a small angle theta with the vertical? And see, they have charge q. Each tennis ball has charge q. So we know the like charges repel each other. Okay, if these two tennis balls possess like charges, that is plus q, they will repel each other. So they cannot remain close to each other like this, as shown in the figure. What will happen? due to the repulsive force, these two tennis balls will get separated like this, as shown in this figure. So this is the equilibrium position. Due to the force of repulsion, the two tennis balls are separated by a distance d. And see the angle, this is the angle mentioned in the question, theta. From the vertical position, the thread is deviated through some angle theta. Okay, now what is asked, the equilibrium separation between the balls. This is the equilibrium separation d. Now let us solve this. See the diagram. I have magnified this portion, that is this portion of the diagram. Here this T represents tensional force in the thread. In the thread there is a tensional force, and another force, this Fc, is the Coulomb force. Coulomb force means the by Coulomb's inverse square law, these two charges experiences repulsive force. See, this charge will push that is this tennis ball, due to this charge will push this tennis ball in this direction. Okay, similarly this tennis ball will push this tennis ball in this direction. So both the tennis balls will experience force in opposite direction. Just we have shown only one ball here. So this ball will experience a Coulomb force in this direction, that is called Fc. C stands for Coulomb. So this is Coulomb force. And see the weight of the ball. Weight of the ball is nothing but the gravitational force acting on the ball, which is always directed downward, that is mg. This is weight of the ball. Weight of the ball is nothing but the gravitational force acting on the ball, that is mg, which is acting vertically downward. So now we have three forces. One is the tensional force along the string, another one Coulomb force, another one the gravitational force, that is weight of the tennis ball. Now let us resolve this T, that is tensional force, into its rectangular components, two rectangular components, because this T is neither vertical nor horizontal, it is inclined. Okay, so it is resolved into two rectangular components. See, if this angle is theta, then this angle also will be theta, because they are alternating angles. Okay, so if you resolve this T into two rectangular components, this component will become cos theta, it will become T sin theta. Okay, and see, in equilibrium position, that is these two balls remain stationary as shown in the figure. Okay, which means the net force acting on them, or net forces acting on the balls is equal to 0, which means all the forces are balanced. So here the Fc, see the diagram, Fc is balanced by T sin theta, and mg is balanced by T cos theta. So we can equate in horizontal direction, we can equate T sin theta equal to Fc, and in vertical direction T cos theta equal to mg. Okay, T cos theta equal to mg. T sin theta equal to Fc means Coulomb force by Coulomb's inverse square law. Just now we have discussed Coulomb's inverse square law. What is the formula? 1 by 4 pi epsilon naught into q1 into q2 by r squared. Here the two charges are, this is q1, this is q2. Q1 into q2 means q into q. So if you multiply these two, q and q, you will get q squared. So here we have put q squared by the distance between the two charges. Here we have assumed the distance between the two charges is d, so d squared. Instead of r square, here we have put d square. So this is according to Coulomb's inverse square law. Then T cos theta equal to mg, from the diagram we have written. Now just divide 1 by 2. Divide 1 by 2. Left hand sides are T sin theta by T cos theta equal to right hand side this portion 1 by 4 epsilon naught q square by d square by mg. So we can write multiply by its reciprocal 1 by mg. So what we get, T get cancelled, sin theta by cos theta tan theta equal to rest of the things, q squared by 4 by epsilon d squared by mg. This, let it be equation number 3. Okay, now From the diagram in this portion, see this portion here, we have a right angled triangle. In this triangle, if you find sine theta, theta is here, sine theta we know opposite side by hypotenuse, so this is opposite side. The entire length is d, so this is half of d, so this is d by 2. This side is hypotenuse because 90 degree is here. Hypotenuse is opposite to the 90 degree, so this is hypotenuse, so opposite side by hypotenuse, d by 2 by l, this is sine theta. So sine theta equal to d by 2 by l, so d by 2l sine theta. This theta is very small, so if theta is very small, we can write tan theta is nearly equal to sine theta. So we can equate these two equations 3 and 4. Okay, left hand sides are equal, so we can equate right hand side. So right hand side q square by 4 pi epsilon d square by mg, it is here, equal to here right hand side d by 2l, we have equated. So just we want d. Okay, so if you cross multiply these things, d squared into d, you will get d cube equal to, all the other things are brought to one side, so q squared into 2l, then in the denominator 4 pi epsilon naught mg is here. See 4 pi epsilon naught mg, this 2 and 4, how many times 2 2's are there here, so these 2 get cancelled and here you will get 2. So d cube equal to q squared by 2 pi epsilon naught mg. So taking cube root on both sides, if you take cube root on both sides, you will get d here and here, this things whole power 1 by 3 if you take cube root. So this will be the answer, this will be the separation. See the options given in the question, these are the options: option A, option B, option C, option D. So out of these 4 options, the answer is what we have got: d equal to q square l by 2 pi epsilon naught mg power 1 by 3. So the answer is d equal to q square l by 2 pi epsilon naught mg, q square l only, not l square, l only. So q square l by 2 pi epsilon naught mg. So here q square l by 2 pi epsilon naught mg power 1 by 3. So this will be the answer for this question. Okay. So in next videos, we will solve more questions in Coulomb's inverse square law. Okay. Thank you.